So what rules do we know? What's the derivative of secant? Okay. What's the derivative of tangent? Just reminding you of things you should know, okay? What is the integral of secant? Natural log of secant x plus tangent x. And what's the integral of tangent? Negative natural log of cosine x. And what's the integral of secant squared? Tangent. Okay. Two more things that I need to tell you. Both are identities, and so it's just identities that you need to know. You know how with sine squared and cosine squared, how sine squared of x equals 1 minus cosine squared of x, and cosine squared of x equals 1 minus sine squared of x. Similar thing here. Secant squared is 1 plus tangent squared of x, and tangent squared of x is secant squared of x minus 1. Alright, so like we did with sines and cosines, and we said if you have this power you do this, if you have this power and do this. We have similar kinds of rules. So we're going to start off with a problem that you can do it two ways because I think it's interesting for you to see it both ways, and that way I can explain what's going on with both ways. So we're going to do number 28 on the section that you'll be doing, and it's the integral of tangent to the 5th of x times secant to the 4th of x. So we're going to let tangent be the odd power here. And we're going to do what it tells me to do for that. Okay? We'll worry about the secant being even, and I'll show you another way in a minute. Okay, what it says when tangent is odd is, I'm going to read what it says. Save a secant tangent factor and convert the remaining factors to secant. Okay? The reason you want to save a secant tangent factor is because we know that the derivative of secant is secant tangent. So we're going to let secant be u at some point. Okay? So we're going to have to save a secant tangent, and it says convert everything else to secants. So what you're going to do is we have tangent 4 to the x, we have a tangent that we're saving, and we're not going to worry with this secant right yet, but this part is the part we're going to change. Okay, so what thing up here do you think we're going to use that will help me change? That. Set tangent squared of x equals secant squared of x minus 1. It is squared, and which is another reason I'm working it out, because I don't like it when it's squared. So, okay. Okay, so what do you think we'll do next? Square out the secant squared x minus 1. So that's secant to the 4th of x minus 2 secant squared of x plus 1. Okay. Alright, it tells me to save a tangent secant factor. So what I'm going to do, which I think will make it easier and less things to write, is I'm going to multiply this by secant to the third of x so I can have my tangent secant to the side. Okay? So I'm going to have secant to the 7th of x minus 2 secant to the 5th of x plus secant to the 3rd of x. And then each of them are multiplied by tangent secant. All right, questions so far?
Can you explain that one more time?
Yep. Okay, so the reason we save that secant tangent now is that we want u to be secant and we want the derivative to be secant tangent. So each of these are u. Now, you can multiply it all out and have secant to the 7th times tangent secant and that times tangent secant. Or you could just think about the fact that that's multiplied by all of them, so it's du on all of them. So really these are all just u to the powers. So this would be secant to the 8th of x over 8 minus secant to the 6th of x over 6 times the 2 is 3. And then secant to the 4th of x over 4, and then that's our answer. We're going to do the same problem, but this time we're going to consider the fact that secant has an even power. Okay? If it's odd for tangent and even for secant, you can do it either way. Okay? If only the tangent is odd and secant is odd, you still do it the odd way for tangent. Okay? And then so on. I just want you to see with the same problem how you get two different answers, how the answers do come out to be the same, but they look very different. Okay. So what you're going to do on this one is you're going to let u be secant. Not secant, tangent, sorry. I did that wrong. If u comes out to be tangent of x, du is going to be secant squared of x. So looking at the information that you see up there, what do you think they were going to do if we want u to be tangent and du to be secant squared? We need to do something with the secant squared. So when tangent is odd, you change the tangent. When secant is even, you change the secant. But you leave a secant squared term out. Okay? So we're going to have tangent to the 5th of x. We're going to have a secant squared of x that we're going to leave. And then we're going to change our secant, the other secant, to this formula here. 1 plus tangent of x. Tangent squared of x. Okay, because secant squared is the separate thing that you're leaving out, I'm not going to multiply it. I'm only going to multiply all the tangent stuff out. And so you get tangent to the 5th of x plus those two things that are multiplied. And then you multiply by secant squared of x. Now we can use our u that we came up with. And so it's similar to the last problem, how we said u to a power and u to a power. Same kind of concept. So this is going to be tangent to the 6th of x over 6 plus tangent to the 8th of x over 8. Notice on this method, it is much easier. However, there is another problem similar where there's an odd power of tangent and an even power of secant, and the other way is harder. And it just depends on which one has the bigger power. You see how all we had to change was one of these secants? That's why this one was easier. If all you have to change is one of the tangents, that's when tangent is easier.
So if you got both of them that work out.
Okay, so another method is when you only have tangents, and this is just an example, so it's not a problem from the book, but it's going to be tangent to the 4th of x Notice there's no secants there. So, like, if I wanted to do a u substitution, there's no secants there or anything. Which makes me think, well, maybe I need to make some secants or something like that. So obviously, like on a problem like this, I'm going to have to change something with that secant squared identity. The rule says when there are no secant factors and the power of tangent is even and positive, convert a tangent squared factor to a secant squared factor, and then expand and repeat. Okay, so here's what it means. That I'm going to leave this tangent alone, and I'm going to change the other tangent squared to our identity, which I told you at the beginning, which is that tangent squared is secant squared minus 1. Okay, question so far? All right, now I'm going to multiply it, see what happens. So I can't just set up a u and a du and say, oh, this is going to be it for the whole thing because we have two separate sort of integrals here. Just think a second about this one, because this is the one that we might be able to do something with. This one's kind of strange. I'm not sure about that because there's still no secants, but there's a secant here. So what do we think we're going to let u be? Is u going to be tangent or is u going to be secant? Okay, so if u is secant, du is secant tangent, there's an extra tangent. It's not going to help me. Has to be tangent. Okay, so I'm going to do this separately and sort of separate it into two integrals. This one over here, I can go ahead and figure it out. U is going to be tangent. Du is going to be secant squared. That's nice because that's just the integral of u, which now we know is tangent of x squared over 2. Oh, sorry. U squared, so tangent to the third over 3. Okay, so what I told you about the rule was, when I read it, was when there's that tangent and no other secants, it said to change one of them and repeat if necessary.
If necessary.
So do you think that this is the if necessary part? Yes. So we're going to change this to secant squared of x minus 1. Does that make sense what I did? How does that help me? Don't want to do use u and du because du's got to involve more secants and tangents. Antiderivative of secant squared x is just tangent, so this is minus tangent of x. Antiderivative of 1 is x, and we got these two minuses, so this is plus x, and then plus c. Okay, so the fourth rule is when there's no tangents, okay? When it's only secants. Now, I'm not going to do this problem because in the work that I have seen, there's only one problem, and it involves integration by parts. At this point, I want you to focus on what we've done so far and understanding how to change those. And when we get to the point, maybe next week, where we're feeling better, we might do the one where there's only secant. It involves integration by parts, and it's kind of strange because of the way you have to set it up. Totally different from these, okay? So that was like the fourth rule, when there's only secants. Okay, the fifth rule is actually my favorite because it's one that changes everything to sines and cosines, and when it's to sines and cosines, I know how to do those because those are like u substitution with sine and cosine are easier. Okay, so that's the problem I want to do last. And it's the integral, and it looks weird, but I promise you that it'll work out okay.
Is this going to take more than this much paper?
Secant of x over tangent squared of x. Okay, so if I think about all the rules that I've told you so far, like about the powers of secant being even and positive and tangent and all that kind of stuff. The fact that we have the squared of tangent, it is even, but it's not positive because it's on the bottom. And the secant is odd, but it's not to like a squared or a third or a fourth. So it seems that the other rules don't apply, okay? And when that happens, this is when you change it to sines and cosines, okay? So secant of x is 1 over cosine. Okay, tangent squared of x is on the bottom, and tangent squared is sine squared over cosine squared. But it's on the bottom, so I'm going to flip it, and I'm going to make it cosine squared over sine squared. Okay?
Would that be negative or positive?
It's positive because I just flipped it.
Okay.
And then just simplify a little bit. So we have cosine x over sine squared of x. Because sine is the part raised to the power, I'm going to let u be sine. And du is going to be cosine. So this is just the integral of u to the negative 2. And so then I want to do the antiderivative, which really just means I want to add 1 and divide by it. So I get negative sine of x to the negative 1 plus c.
That's what they don't do.
Yep. Okay, so I want you to do, it's this page. You've already done 28. We did two different ways, so you can totally skip 28. But 23 is the one where secant is raised to a power by itself, and where it's an odd power and there's only a secant. So that's the one that we're going to skip for now and maybe come back to later.